Hey there everyone, Slippery Slope here with Java tutorial number 23. This one is on the math class, and hopefully you're not going to crack a bunch of corny jokes about 20, 30, 40, however many people sitting in a room and learning from a teacher how to do 2 plus 2. That is so not cool. Don't make those jokes, or do, because I have a corny sense of humor. But this might come off as a little dry because I'm not going to show you guys how to type up several lines of code and put together a program. I mean, technically it's a program, but it's nothing complicated. Hell, anything's a program. Ooh, I said a swear word. I'm sorry. So here's the thing. I'm going to show you guys how to do 1, 2, 3, 4, 5, 6, 7, 8 different methods of the math class. And let's just get going. There's no more need for interruption. Pardon the interruption, kind of like the ESPN show. So this is math.py of the math class. If we run it, and you can probably guess what it does, it gives you pi. And we could memorize all of the places after the decimal of pi that Java chooses to give us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Sounds like a double to me. We could do that, but I just wanted to show you guys how to do pi. And if you wanted to find some formulas, you could put in times radius, and try to find the area of a circle or something. But what the heck, why not? Integer radius equals 5. Run it, and the area of our circle would be 78.5 something something. So that's how to do pi. And I don't want to delete this system.out.print because I'd have to type all that stuff up over again. Not that it's that much, but let's try another one. This is a concept you might be more familiar with. It's absolute value. So let's say we wanted the absolute value of -3. And run it. Java will spit 3 out at us because remember, an absolute value is how far the number is away on the number line. So how far is -3 from 0? Well, it's 3 spaces. How far is 3 from 0? Well, it's 3 spaces. Next up, I'm going to try. I know how to do this, silly. Math.ceil. And let's just enter a floating point number that isn't just the regular old integer. Let's try 22.12. And I have a bunch of parentheses. I don't know how that, there we go. And run this, and what's going to happen is 22.12 goes up to 23 because it sees, oh, you don't just have 22 here, you have a little bit extra hanging out. I mean, if it was 22.0, Java would still say, oh, well, you have 22. But if I put in 0, 0, 0, 0, 0, however many zeros I just put in point, and then a 1 at the end, yeah, there we go, it would go up to 23. So, oh, you know what, one more thing. Just keep throwing in zeros and run this, and you still have 22 because Java just looks at that and it blanks. So let's not do that. Likewise, the opposite would be if you want to do math.floor and you had 17.9 and you run this, it will not round up to 18. It'll go down to 17 because that's the integer closest to 17 on the downside of things. So if you did ceil, it would go up to 18. Because we did floor, it goes down to 17. A couple more things, and honestly, I think all of these so far and all these in this video will be of use to you at some point. So I'm not saying memorize them, but if you just want to jot down the different ones I'm using, feel free to do that, or consult your textbook later on, or the API, or whatever. And yeah, just know that this stuff is here. If we wanted to do the power of something, let's say 2 to the 12th, run this. You have 4,096, because what we had was 2 to the 12th. The second number would be the exponent, and this would be the base. So just to go with the smaller number, 2 to the second. Well, then you'd have 4. Though that's not too convincing because you might think, oh, it just multiplied. 2 times 2 is 4, or it added. Instead, 2 to the third, well, that would be 8. So there, 2 times 2 times 2. I proved it. Hurrah. Let's go ahead and try square root, SQRT, almost like wort, except no vowels. And the square root of 36, you might know this one already, is 6.0. So Java throws a floating point number back at us because it's prepared to do that if need be. So we get a 6 because it squares perfectly, squares nice and evenly. And 2 more I want to show you guys, and then that's really it for the math class for now. Is math.max, and let's just say I keep throwing in a bunch of numbers. 1, 8, 79, 50, 42, 27, 888, and I just have like all these numbers hanging out inside of here. Well, first of all, I get an error, because the method max and the type math is not acceptable for the arguments n, because you can only use 2 numbers at once. So that might not sound too useful to you, 888. But do keep it in mind, because when you start coming up with algorithms, which means that you're going to try to come up with complex ways to solve problems mathematically, you're going to want to know this. So likewise, if we did the min, this would pick the smaller number of the 2, 1888, and I could put in 44. And I would have to get rid of the 1 so that we still have 2 numbers. And keep in mind that we can do floating point numbers as well. Thing is, Java interpreted a regular old 888 as an int, and these, well, it's like doubles to me, because I could just put this beyond the amount of places you would expect a float to be, and I would have to make this one bigger than the other one, because otherwise Java would not care what the decimals look like, because then no matter how many numbers I put after here, it would be bigger than 1,000, because it's still only 888. So, yep, now it's bigger, and Java starts spitting stuff right back at us. What we put in gives us the smaller of the 2 numbers. So yeah, that's just 1, 2, 3, 4, 5, 6, 7, 8 examples of the math class. Don't worry about memorizing all of this, but do keep in mind that it exists, and that when it comes up in future videos, you'll know what it is. So thanks for watching. If you like this video, feel free to subscribe. Slippery Slope signing out. Peace.